Josh. This is Jace. We're out here at AquiPor's R&D and product development facility. And thank you all for joining us today. Today, pretty simple. We wanted to do a live demonstration of our concrete pour. So integrating AquiPor's technology into what will be basically a ready mix or pour in place type concrete application. We'll go like 15 minutes. This pour won't take long, and then we're going to open it up for Q&A. So this will be pretty quick. I know people are probably busy, middle of the week. So again, thanks for joining us. Quick update. I think this is super important. So let's talk about like the last 2 or 3 months since we did our last live Q&A or event. In May, we made a trip down to Southern California. We met with the city of LA and a big paver manufacturer and then a very large corporation. And those meetings went really well to the point where the city of LA has given us approved mix designs for basically their approved sidewalk applications in the city. And we are now starting to work our stuff into their mix design to get kind of a finished product and get something that can go into testing for pilot projects. So we're very excited about that. There's a lot of interest that has stemmed off of those meetings from other cities in LA County. So we're busy at work at getting this ready mix and pour in place design optimized and put together for projects we're hoping next year. These would be the bigger pilot opportunities. Before that, let's talk about what we did. I guess it was in April. This is a big deal for us. We did our first commercial production run of pavers where we used concrete aggregate material. This is our technology. We process into aggregate. Obviously, that goes into normal concrete. You see 2 different fractions. This is like a larger fraction, more like a 3/8 fraction, and this is more like coarse sand. And so anyway, we implemented these into pavers, and this was the finished product. These are ready. We have pallets of these ready to go for our first projects. This is commercial worthy, commercial ready product. Josh will give a quick demo. Product demo. And you can see how permeable that material is, extremely porous. And this is just like a normal concrete paver with the big advantage of permeability and filtration. So the pores are very small. This is not like pervious concrete. It looks like Rice Krispie treats that will clog up over time. Totally different application. So very exciting last couple months. We have some, I think, pretty hot coals in the fire, and continue to update you as these things come together. Now, should we get to the demo?
Yeah, let's do it. What are we going to do, Josh?
All right, we're going to pour a couple 100 pounds of a 2,500 PSI sidewalk mix that we've been working on with AquiPor Incorporated for the permeability and porosity. Jace, you want to kick it off?
All right, let's see it, Jace.
So what we're going to do now is show you guys how this mix is the same as the regular concrete mix, just with AquiPor inside. Show you how easy it is to implement.
So what just happened there?
We're getting the aggregate. This is the first portion of aggregate into the hop.
Rocks and sand.
Yep.
Okay.
And then we'll add the cement, water, get that mixed in, and once that is a nice texture that we like, we'll throw our AquiPor in, mix it for another about 30 seconds, 30 seconds a minute, and then we'll pour a couple stair treads.
Okay, cool.
Yeah, and so this mix is indicative of what you can do in a precast facility. So precast facility, you can do this pour in place as well. So literally pouring sidewalks, pouring streets, or at least street shoulders, parking lots, alleyways, all the above.
Adding our type 3 Portland cement, which is the standard around here. Type 3 is just quick set. It's good for the precasters because they're able to break it out of the form the next day.
What's that one?
Cement again. Top of the cement portion there. Simple. It's just bucket pouring concrete. Day like today, I'll feather the water in so we make sure we get the proper slump. Then we add aqua material and we're ready to go. Because our material is porous and pre-saturated, but we do like to make sure the slump is proper before you add our material, just for consistency and final.
Talk loud.
So this is totally scalable. We're doing this as a demonstration for. Now here, this is Kevin Stoker. So he owns Stoker Precast, our strategic partner. And I'll let Kevin talk about how scalable this is from here, like literally we've been doing it in even smaller mixes, to here all the way up to much larger.
Yeah, so basically everything you saw them do with buckets, this is a state-of-the-art batch plant where basically cement, water, aggregates, it's all run through a computer. All of our mix designs are pre-programmed. We can have up to 100 mix designs in this guy. So all we do is we load the bins that are back behind the building that come up through the conveyor, and then depending on the mix design, water is automatically added. Add mixtures are automatically added. So kind of the old school drum mixer method that you see is just for demonstration here for doing a small pour, but there's absolutely no reason why we can't be adding AquiPor aggregates to our bins and running it like we would run any other concrete mix to our batch plant.
Yeah, that's a good point. Why don't we show them the paver again and tell us about the first commercial run that we did at White Block?
So these pavers were made at commercial scale like we talked about. We did this with a paver and block manufacturing company here in Spokane. This mix is called, or is considered, a dry cast mix. So it's a much drier mix than what would be precast or pour in place concrete. And so it's actually a really good point is this is extremely permeable because it's a little looser mix. Our precast sidewalk panels and any ready mix pour in place application isn't going to have quite this permeability just because it's a wetter mix. But Josh, you can pour some water on here.
So you guys will notice when the water hits, and I'll feel if you can get down and see, but you'll see micro bubbling across the whole surface here. I don't think our microphone is strong enough, but you can also hear suction noises as the water is being pulled into the surface there.
And what's really unique about this, because the pore size is so small, you have the filtration capability, but what will happen is we'll finish this pour, we'll come back to this panel and it'll be dry. And we're inside, right? So if this were out in the sunshine, this would already be drying up right away. It's already.
Yeah, you can already see all the
There
what
was
it's
a
like.
pool of water here just a minute ago, and when I move my hand, you can see all these little micro bubbles. That's our fine pores where the water's entering.
Yeah.
Cool.
So super unique technology. There was a video that went viral again a week or two ago, and it's pervious concrete basically. And I'm curious how or why it went viral again, because the product was actually shelved, I believe, in like 2021. But it shows, you know, this concrete pavement, pervious pavement, taking on like 4,000 tons of water. They claim in a minute. Well, the reality is, in the real world, there's no soil that can handle anywhere close to that amount of water. And so suddenly you're going to have to engineer a whole system underneath that. It's going to be very expensive. And when we're talking to engineers in cities, what they're saying is if you can get like 1 to 5 inches of permeability, that's almost the sweet spot so that this can interact naturally with the soil type in a given area.
Nice.
So add on top of that the filtration capability, and I think we're on to something.
All right, what do we else
So
got?
I'll show you guys the magic. Today we're using a finer grade of our material for this particular mix design. But like Greg had mentioned before, we've got all different sizes for different permeability, flow rates. They all filter, and then when it comes to strength, we can adjust the mix design and cater to whatever the needs are of the end user. So we got nice concrete. Looks a little wetter, but that's because we haven't added our piece.
This is great, everybody. We'll
You guys can see it's incorporating into the mix. Get a slight shift in color, but we think it looks good. Now we're ready to get this into a form.
Cool. We'll get this into a form, and we'll probably get to questions, everyone's questions, in just a few minutes here, maybe 5 more minutes or less, and we'll be ready to answer some questions. So stay tuned for that. It's coming up in just a couple minutes here.
It's just literally pouring concrete. What we're doing is we're taking AquiPor's technology and we're putting that in place on some of the normal aggregate that would go into typical concrete mixes. And when we do it in the right proportions at the right size, that's what facilitates the permeability, the porosity, and even the strength. I think there's something our material's doing to the concrete mix where there's some internal curing going on. So we're getting maybe some additional strength in concrete. And what that means is now producers can maybe start using less cement in their overall mix. So it's very simple. I know it doesn't look like much, and that's the whole point, is like we wanted to get this to the point where it could be integrated seamlessly so that whether you're a paver manufacturer, precaster, or ready mix guy, or gal, or company, right, you can do this very easily.
Great. Yeah, so just this is like a precast right here, but yeah. So.
Yeah, this is precast, but pretty much similar mix as to what you would do in a ready mix scenario. And Josh, maybe you can talk about some of the testing, just in real general terms of what you've been doing for those things.
So what we've been working on, once we get a hold of their official mix designs, is the incorporation of our technology into the mix design. So depending on the size class that we're putting in there, depending on what PSI they want, what their flow rate needs are, we will basically swap out equal sized portions of their aggregate and incorporate ours. We use the same amount of cement, exact same sieve sizes of rock, sand, everything in between, and then throw AquiPor in and things start working real good.
That's great. You guys
These are a couple samples. These are pavers, okay, because they're just samples. We wanted to sample these designs. But this is ready mix. This is like the same mix design that we've been working on for a couple of these municipalities. This would be like a sidewalk mix design. Pour some water on here. This is kind of a looser finish.
Yep, so as you'll see here, we got different finishes on the surface, all the way down to, you know, a couple of these. This is too loose. We're trying to stay away from this, but this was an early model that we were working on. Then we started tightening things up. These pavers that are two color, it's because we've done an acid etch, a light acid etch to increase the permeability. And you can see you don't actually need the acid etch for permeability, but sometimes it makes it have a cool look, brings out that stone. So these are just options.
Yeah.
Which
I
you
guess
guys
the,
will.
yeah, the point is it's like it's very versatile. The technology is super versatile. And really the concrete industry, they're the experts, right? We're gonna give them a tool, a new tool to be able to do a whole bunch of different things with their concrete. And so we're
Cool.
pretty excited.
You guys want to maybe do a little Q&A now, or?
Let's do it. Yeah.
Cool. Well, we're heading.
Can you get that sound?
No, I couldn't quite get that sound, but yeah.
We'll head into the here.
Cool. Let's set this down here. Look at this, right? Yeah, just stands shoulder to shoulder pretty much to stay in frame here. Okay, cool. All right, so yeah, everybody watching, we're gonna do, you guys sent in some questions and there's some questions coming through. So we're going to just get you, you know, so first off, the questions we always get. Somebody explain to me what happens on freeze thaw. We know it's coming, so let's answer that one real quick.
Well, what we can say is our material is into third-party testing right now. For rapid freeze thaw, what we have done in-house is, and Josh is grabbing a couple samples, we've done our own freeze thaw tests. We believe that our technology naturally air entrains concrete, and so air entrainment agent is something that mitigates rapid freeze thaw. It holds concrete together. Ours does that naturally. We've had an installation in the field over the course of a pretty harsh winter, typical winter in Eastern Washington. No cracking, no deterioration. But until we get that third-party data, we're not going to make claims outside of what we've seen in-house. And there's been no cracking, no deterioration. So again, I think our technology naturally air entrains concrete.
Cool. I don't have these all in some specific order, but I'll try to ask them. So, you know, here's a good question that we all get, and it kind of goes to some other questions people ask, you know, about like sinkholes and how you have to engineer something. So one of the questions we got was, before pouring the concrete, is the ground treated, and what type of ground is it placed on, and can it work on sand?
So one of the examples we actually got from our trip down to LA, they saw our dry cast paver and they said, wow, that's incredible. Let's pull out the geological information maps. And basically their soil can only infiltrate about 7.8 inches an hour, which means if you're doing 30 inches an hour, you're gonna have problems. So they actually asked us if we could slow it down. And that's what's nice about our technology is we can cater it to the needs of the end user for the strength, the permeability, and porosity. Yeah, you're saying.
Yeah, and yes, that's actually a good question. Yeah, you do want to, I guess, quote unquote, pre-treat the ground. You're going to have subgrade, and you're going to base your subgrade or the subterranean sections of the installation based on the natural hydrology of soil. So if you have soils that only drain 7.5 inches, and then you take the annual rainfall rate of a given area, you put those numbers together, and that's going to determine how deep you want the subgrade and the subterranean layers to be.
And the other piece of this, which it's going to be easier to understand at large scale, and when you do the math, that's when it really starts making sense, 1 inch, 3 inches an hour. So you look at 1 inch of rainfall in an hour. It's not a lot of water, but when you have acres and acres of impermeable surface, all of that 1 inch of water shunts into a smaller area. Now you have depth, and that is the problem the cities are dealing with. What our product is designed to do is prevent that 1 inch from ever leaving the acre of land it's on. Thus, you will never have a buildup of water where you do have to worry about overloading existing systems, infiltrating so much water at such a high rate that you could, have sinkhole or soil deterioration issues below the install.
Yeah.
Cool, perfect. I also, one that we kind of usually get, but it's also a good one. Does it clog over time?
From what we've seen in-house, no. This material and the porosity is so small that it is filtering the vast majority of total suspended solids and things that are at the sub-micron level. And so that material, stormwater pollutants, particulates, again, TSS, suspended solids, that's in stormwater, it will lay on the surface while water goes through. Now, over time, that accumulates though, and that's gonna slow down the permeability rate of the material. And so it does need to be maintained over time. But what we're seeing is even just a normal vacuum sweep, it gets the permeability rates almost back to the optimal levels. And so this is a totally different way to look at permeable concrete, because what's been out there in the past is just large void space pervious concrete that can take on a lot of water initially, but all those voids get clogged up over time. What's even worse is the subgrade gets clogged up over time. And once that happens, the whole system's impermeable. And so our material, it's more akin to like a filter. It's like a concrete filter technology.
And that surface filtration is going to translate to a longer lifespan of the installation.
Awesome. Here's kind of a fun question. With the upcoming F1 movie as inspiration, could your tech be applied to racetracks where heat, tire stress, and wear impacts concrete? Thanks. I guess they're talking about if there's like rain events there too.
I love that idea, and we've actually been thinking about airports, basically any place where you have high traffic, high speeds, and you don't want to have slippage, but you're going to have rainfall. Yeah, I think our stuff could be pretty revolutionary when it comes to that.
Yeah.
Okay, cool. Another question here is, one person was asking, and I think this is really great. Have you where was that? What are the plans for distribution of AquiPor aggregate to retailers like Home Depot and Lowe's so that it could be used by DIYers, homeowners, and contractors?
I think that's certainly a possibility. That's going to be down the road. So our plan right now is we're making, a couple tons of our material a week, right? So very small scale. Plan is to scale up here at this facility to about 1,000 tons a month would be amazing. That's going to get us far down the road of being in the market, providing material for bigger projects. And then at some point, hopefully in the near future, we're scaling that to say 30,000 tons a month. But we are going to, basically create market demand for this and then scale up responsibly. But at some point when we're at that type of scale, I think this is certainly something that could be almost a bagged retail product at some level. And so yeah, it's certainly a possibility, but
One of the
we're
things
focused on the next step.
One of the things we've been playing around with is, your Quikrete or your pre-bagged cement, simple cement that you would use for fence posts or whatever. And we actually swap out portions of the aggregate, add our stuff to that, and we're getting impressive results with permeability and strength.
Yeah, so it could be like a one bag mix where it's just a bag of concrete already with AquiPor inside.
Yep.
For do-it-yourselfers.
Awesome. Okay. We don't have a ton of extra questions other than kind of the normal ones. So we'll kind of pivot a little bit here. And then here's kind of a fun one. Have you considered documenting your carbon emissions to generate additional revenue stream?
We have. In fact, I have a call next week with a company that does life cycle analysis and EPDs. And so I'm going to start getting information about how we go through that process. So it's certainly, that's on the list. But I think also, that's something that we're going to want to have as we scale up into the market. I think that's where it matters the most. And I think some of those certifications can be expensive initially. And so it's definitely something we're looking at. And I'm going to make kind of the first step next week with getting more information on that.
Great. I think this is a good question that kind of transitions to some other things here. It goes, what does scaling production actually look like for AquiPor? More people, more equipment, additional facilities?
Yep, that's the plan. So there's really three plans. I'll give you the big picture plan. This would be based on us somehow being able to raise like $50 million. And this is a real plan that I've put together because I think it's a good thought exercise for how we would scale something like this. And that includes probably 3 to 5 facilities regionally throughout the US, and then blitz scaling pilot projects in say like 25 municipalities, and then obviously having a team. So regional teams, sales teams, marketing teams that go out and service those markets. That's a real possibility. But again, that assumes we somehow would be able to raise that amount of money. And that's like a 12 to 18 month plan where we scale this up very quickly. Plan B would be more like a $4 to $5 million raise, where that plan is in effect but is tapered. And then plan C is what we're doing right now with the cards that we've been dealt, which is we're kind of seed strapping, right? We can produce enough material here to get into our first projects and then look at licensing the technology to various companies, paver manufacturing companies, ready mix companies, while at the same time, so our capital outlay for that is very low, but at the same time still being the tip of the spear, the sales and marketing piece to cities, to large developers, where we can kind of manage those relationships. And so to answer your question, it's going to be somewhere in between all of those.
Okay, that's great. This will be a great question. So in the future, then, what kind of pricing models are you looking for with AquiPor products, and how competitive do you think they can be to existing concrete?
Well, that's a really good question. One we get all the time. This is when you implement our technology, it's going to make concrete more expensive, especially initially. When we get to an economies of scale with the raw materials that go into making our technology, that cost is going to plummet. But we are going to be more expensive than, say, a cubic yard of concrete today. And whether that's 1.5 or 2 times, we're still kind of dialing that in. But what we also know is it's not even a fair comparison, because when you're just pouring a yard of concrete as your sidewalk, say a mile of sidewalk, a mile of street section, you have to account for all of the other engineering that goes into that, all the gray infrastructure, the stormwater conveyance, storm drains, everything that goes into that street or sidewalk to convey stormwater to the treatment plant. Whereas with AquiPor, you're solving that issue, but you're just doing it right where the stormwater falls, and you're doing it with concrete. And so we've also modeled out 1 mile of ours versus 1 mile of normal sidewalk, including all the infrastructure that normal traditional concrete needs underneath it. And what this ends up being is a lot more cost effective for cities. So that's the more fair comparison, I think.
I think maybe give them a little example. Talk about like the housing development in Austin that's reached out to us, and other places, like how those are examples, you know.
Yeah, we've gotten a lot of inquiries. One we're excited about is a development in Austin, Texas, kind of a higher end community where they have requirements for the amount of impervious surface area they can have on a property. And so you get rebates or you get some type of subsidy by having pervious, whether it's concrete or something that allows stormwater to get back into the ground naturally. And so those are issues also where this can be a cost saver. I know Nashville has some of the same sort of requirements. We're seeing these pop up all throughout the country where there are requirements now on new developments to have some portion or some percentage of the footprint of that property be permeable.
Perfect. I think now maybe we'll transition a little bit into like how we're going to try to raise those funds, you know, and how we're going about that. Because, you know, some of the questions that we're getting is, you know, like, when do I'm an investor, when do I see a return on that? When do you guys go public? All this kind of stuff. So, I mean, maybe one, just kind of say where somebody who has invested, what that means for them in the next, you know, year or two.
Yeah. So right now, I mean, the plan is we're thinking toward an exit strategy, but the focus right now is just growing, right? Growing the business and doing it responsibly. We have stuck with crowdfunding because I think it's treated us really well through these R&D cycles. We also understand that crowdfunding now, as we get to this inflection point where we're ready to go to market and we're ready to scale up, we may have to look at other sources of larger financing. And a lot of times those come with strings attached. And so it's something that we have to weigh very carefully. When you start wading in those waters, so to speak, there is some control you're going to give up. There's potentially a lot of dilution. And so we've been very cognizant of that every step of the way because, again, the crowdfund investors, everyone that's invested in this company, we're on the same footing in terms of the stock that we own. We all own common stock. And so you get, you know, you start swimming with a few of those larger institutional funds, they want preferred shares and things like that. It can get messy. But that being said, at the right juncture, that's something we will consider. And yes, the plan at some point is to go public, but we also know we have to start growing very rapidly to do that. And I would never, it's not even on my radar to do something that is going to jeopardize the long-term prospects of this company just to get people an exit, if that makes sense. There may be a situation where a big investor comes in later and he offers, you know, he or she or the fund offers secondary shares where people can sell on the secondary market, and that's a possibility. But these are things right now that I think about, but not too seriously, because right now we're just all about growing this and, you know, seeing where we can take the company in the next three to 5 years.
Okay. I think, you know, I think this is pretty close to the end here, so I don't know if there's anything else you guys have top of mind. Otherwise, let's talk about how you can invest, you know.
Sure.
So
I would say, before we get into that, if there's any of you guys out there who are engineers, who are a city, you pour concrete, and you've got mixed designs and you have expectations, get a hold of us, send us some mixed designs, let us know what your expectations are for strength and permeability, and we'll start messing with those mixed designs and get back to you right away and say, hey, we can make this work, maybe we can't make this work, maybe we can meet somewhere in the middle. But the more outside help we have from you, the faster we can do this.
Exactly. And to that point, if you have, and it seems like we have a lot of people that are interested in being early adopters of this technology that might have a pilot project. It doesn't matter how big or small it is. Get in touch with us, because these are all things we're looking very seriously at, you know, right now. I know we're a little bit constrained because we're on the West Coast and we get inquiries from New Jersey and New York and Miami, Florida, for example, but these are all things that we can start planning for, and we will look at every opportunity very seriously. So if you have a pilot project in mind, same thing, just get in touch with us.
you know, we actually got a couple of questions last second here that I just am now seeing that I think might be kind of fun. Some from some friends of ours. Can you use any kind of, is there any kind of coating, paint, or stain, or is that possible to incorporate coloring that won't clog the pores?
Yep.
Yeah, I think colors, color additives we've already played around with, and those work fine. Paint, you know, any latex.
You don't want to paint them.
Yeah, I think that is going to cause clogging issues. So there's going to be some limitations, but you can still color your concrete like you normally would with dyes or powders, liquid dyes or powders. Yeah.
Okay.
Yep.
What about, could it be stamped or textured?
Oh yeah. We actually have textured forms, and then like we were showing you guys earlier, we play around with different etches. There's a treatment called top cast, which people use for their garage floors and whatnot. And it's a super light etch that brings out the grit and some of the beauty of the stone, because some people use really cool stone in their concrete and they want to be able to see them. So yeah, we played around with all sorts of inhibitors, etches, textures.
Yeah.
They actually make it flow better.
Yeah, it's just like normal concrete.
Cool. One last question. Can this work with any type of mixed design? You kind of already covered this, but does water content need to change when adding AquiPor?
Great question. This is an excellent question.
Yeah, so
Some discoveries we just made.
what we've been finding using, because obviously you have to have control, so when we get a mixed design, the first thing we do is make it and test it and make sure that it matches what the specs say it should. Then we work on incorporating AquiPor, and there's a couple tricks you can use, but when we pre-saturate our material, it's going into the mix with water inside of it, but that water is trapped inside of our particles, so it's not actually interacting with the cement paste itself. And it doesn't displace water like rocks and sand do, but we have been noticing I'm actually able to get our stuff into mixes using less water than the standard mix. Now when it comes to workability, I know there's going to be some preferences, and depending on the job, you might need more workability, but you can't go higher on water. So we've actually also played around with using plasticizer, and it works really well because you can keep the water extremely low, keep the workability high, and then you get increased strengths.
Really strong concrete.
Cool.
With permeability. Yeah.
We're getting a couple more questions in, so I guess we'll just keep going for a second here. We're almost done. We go regarding permeability versus structural thickness. How does the thickness affect permeability for pores as thick as like 6 inches or more? Do we know?
So we've actually, the sidewalk panels you looked at, those are about 3 1/4. We've done 4-inch pores, but we have done 10 and 12-inch pores to simulate cast in place, or I don't know where you'd be doing a 12-inch pour, and you probably wouldn't want to use it for the foundation of a house, because in that case you want to keep the water out. But our material gives vaulting capacity, so the thicker it is, as it fills up with water, the permeability, the flow rate is going to decrease, and it's going to match the release rate on the bottom. But ideally you can engineer the amount of AquiPor that you want for your system or your acre of land or whatever it is that you're trying to control the runoff of. You engineer that with the vaulting capacity in mind. And so if you do a thicker pour, you will basically store more water in our material. So those dry cast pavers Greg had, those hold about 10% of their weight in water before they even start releasing water out the bottom.
Yeah.
So a 10-pound paver holds 1 pound of water. So if we're going to get this much water, it becomes engineering math at that point.
Yeah.
Cool.
Good question.
One other question I had a couple times is have you made contact with rebuilding efforts for the LA fires in California? It just seems like that's just a good example of what a good rehab would be.
Yeah, we're kind of making our way, navigating how things work down there. So we made a trip, as I mentioned, down to Los Angeles in May and made the right contacts, I think. That is definitely on our radar. We have some contacts even at the political level. We don't have those directly, but a friend and an advisor of the company does. And so that's something that we're gonna pursue. And right now it's about getting this one mix design optimized and ready that we can hand to the city of LA and start getting that into testing. And then from there, I think, the sky is potentially the limit down there, because there will be a lot of rebuilding Water is top of mind down there. They don't get much rain, but there is a huge, obviously, initiative to get that stormwater back into the ground or be able to reuse it instead of it running off into the Pacific Ocean. And we talked about this almost ad nauseum, but they have some big water issues down there, and I think that's a good place for AquiPor.
Great. Yeah, that pretty much covers a lot of the questions that we're getting in. So yeah, maybe tell people what our need is and how they can help and be an investor.
Absolutely. So we have a crowd fund open right now, equity crowd fund, where you can own shares directly in AquiPor. We are at StartEngine.com/AquiPor, and we have some time left in the campaign. We're really trying to kind of juice up what we can bring in here over the next couple months, because we have some pretty big initiatives in terms of scaling up our production capacity for our material and getting as much made as possible to get into some of these pilot projects. And so I think the dollars invested at this point, they're just all going back into the last finishing touches of product development and a lot into market development and getting our first, clientele in the door and starting to scale up. So StartEngine.com/AquiPor, and you can invest directly right there.
All right, that's good, guys. I'm just gonna fade to black here and say
Thank you, guys.
thanks everyone.
Yeah.